In this problem, we're asked to use Newton's method to approximate the solution to the polynomial 3x cubed minus 3 minus 1 equals 0 by finding the third approximation, x sub 3, with an initial approximation of x sub 1 is equal to 1, and round your answer to 4 decimal places. Okay, so we're going to use the formula of Newton's approximation method. The n plus 1th approximation for x is equal to the nth approximation for x minus the function, the given function, evaluated at the nth approximation over the derivative evaluated at the nth approximation. With the following given information, f of x is 3x cubed minus x minus 1, then we calculate the derivative at 9x squared minus 1, and we use the first approximation, x sub 1 is equal to 1. Step 1. Find the first approximation for the solution to the given equation. That was given to us. We didn't have to calculate it. X sub 1 is equal to 1. All right, that's given. Step 2, we're going to find the second approximation, customizing Newton's formula for x sub 2. That's equal to x sub 1 minus the function evaluated at x sub 1, that's the first approximation, over f prime evaluated at the first approximation, x sub 1. Well, the first approximation, x sub 1, is equal to 1, so we just plug in 1 for the numerator and the denominator function. And we simplify that. X sub 2 is equal to 1 minus 3 minus 2 over 8, which is 1 minus 1/8. So the second approximation for the solution to the equation is x sub 2 equals 7/8. Now that's closer than the first approximation, that was 1. Each iteration gets us closer to the accurate answer. The third approximation, which is as far as we're going to go for this problem, they asked for the third approximation, gives us we'll use a formula x sub 3 equals x sub 2 minus f evaluated at x sub 2 and f prime evaluated at x sub 2. So use the f of x and the f prime of x that we listed at the beginning of the solution, and that gives us a mess. We're just plugging in the 7/8 every place for the x's. And then we have to rely on our algebra superpowers from the old days. We have to get a common denominator in the numerator of this fraction. And that's going to be interesting, but it's going to be 512 for the common denominator. And in the denominator, the common denominator in the bottom is going to be 64. So yeah, that's what we're getting a common denominator. That's what all this work is about. We have to do the same thing on the bottom so we can subtract those fractions. And when we're finished, we're going to get 7/8 out in the front minus a complex fraction. We have a little fraction in the numerator, a little fraction in the denominator. And it simplifies eventually to 7/8 minus 69 512ths over 377 64ths. Now that's going to be an easy a fraction to simplify. We just take the top 69 over 512 and multiply it by the reciprocal of the bottom, and that simplifies to what you see here. Then we grab a calculator and we get 0.8521220, and we're going to estimate it to 4 decimal places, so round after the arrow. We get the third approximation is approximately equal to 0.8521. So you'll see what happened was every successive iteration of Newton's method gets us a higher degree of accuracy in finding the solution to the given equation. They asked us to only go to 3 iterations, so that's where we stopped, and we rounded our answer. And this was the way life was before computers.